Well, it's time to start. So hello, everyone, and welcome at Leobit's webinar from traditional automation to AI agents. Well, my name is Uliana. I am Business Development Manager, and I will be moderating today's webinar. Before starting, I would like to share a few housekeeping items. So this webinar is being recorded, and you will receive recordings after it. And at the end of the presentation, we'll have a Q&A session. So please feel free to leave your questions in the chat box below. And I would like also to introduce our great speakers. So the first speaker is Yurii Shunkin, who is our Research and Development Director. Yurii has 14 years of experience in IT, 10 years of experience with AI. He ran our Research and Development Department and has a proven track record of successful projects with AI and ML. And the second speaker is Vitalii Datsyshyn, who is our solution architect, who has also many years of experience and strong expertise in designing scalable architectures. He works a lot with AI, has many successful projects with AI.NET and related, and he will also be speaking about the topic. And moving on, let me share the agenda with you. So as you can see, we have 4 main blocks of technical information and the Q&A session at the end. So we'll start with AI adoption model, then we'll share practical automation case evolution. Afterward, we'll move to AI workflows versus agents trade-offs. And finally, we'll end with adoption roadmap. And now I'm glad to give floor to Vitalii to start with the presentation. Please, Vitalii.
Thank you, Uliana. Pleasure to be here. Yes, so today, many projects require AI adoption for various reasons, automating business processes, eliminating manual work, enhancing decision-making, even attracting new investments, and many more. So in this presentation, we will guide you through our AI adoption model. So we also dive into our practical approach, the techniques and methods we use, the typical scenarios we encounter, and how to choose the right solution to address common challenges. Hopefully, this will serve as a starting point for you to begin your own AI journey if you haven't already. So we have selected one of our projects as a practical example to illustrate our approach and demonstrating how each step is applied and the benefits it delivers. So we will reference this project throughout the whole presentation. So now let me provide a bit more context about this case. The client is a global delivery company serving B2B and B2C customers. Their services include parcel delivery, freight forwarding, custom clearance, and international logistics. Now let's focus on the order process and the shipment process how it was before we started automating it. This process involved a lot of manual work. So as shown on this diagram, depending on whether it's an international shipment or not, it required additional research for custom regulations and requirements. Then manual checks of carriers' websites like DHL, FedEx, and UPC for additional information. Then comparison in just a spreadsheet and selecting one of them. After that, creating a required documentation, filling out the forms, and manually tracking shipments and notifying customers, especially if any delays were detected. The company struggled with fragmented process, manual documentation, and lack of real-time visibility into shipment status. But again, it's just an example, and Leobit's AI adoption model is pretty universal and not locked into this specific case, project, or domain. So now let's take a look at our AI adoption model. This slide illustrates this model as an incremental evolution. In general, our approach is to start simple, prepare foundations that already provides benefits of automation, and progressively move to more complex AI solutions, using previous steps as building blocks to reach the next level. That's why it's evolution and not replacement. We start with level 0, non-AI automation, preparing the foundation. Then we introduce AI with two options. Level 1A, using foundation models with prompt engineering, or level 1B, creating our own corporate LLM. Next, we combine level 0 with level 1A or 1B or even both to create AI workflows that automate entire business processes with predefined rules. The next level, level 3 AI agents, is needed for even more complex workflows where there are no predefined rules, or we need greater flexibility in the process based on different factors. Level 4 multi-agent system is needed for complex automation where we split execution steps among different AI agents and need to orchestrate them. Level 5 is artificial general intelligence, which is actually not invented yet and will exist when artificial intelligence equals human intelligence. Now, with examples, let's go through each of the steps. Non-AI automation is required as a solid foundation before introducing AI. It already eliminates manual processes, establish data governance and connections between existing systems, and also creates a toolkit of actions that will later be reused by AI workflows and agents. Technically speaking, it could be even a simple web application that perceives states and interacts with external systems via API, but it's not limited to this solution. As an example, we can consider creating a shipment tracking dashboard that pulls data from ERP when new order is created, integrates with different external carrier APIs, generates simple shipping web forms, and notify users of any updates. Also on this slide, you can find a few more possible use cases of non-AI automations that could be used to automate purchase order processing, to generate quotes based on specific rules, to route support ticket, and so on. The prompt engineering approach is a quick win as it uses foundation model or pre-trained large language models like ChatGPT, Gemini, etc. It's deployed separately as its own replica of the foundation model, meaning data processed through it won't be exposed or used for training. And an initial version of the solution can be released very quickly, allowing us to prove this feasibility of that solution. So technically, it could be like a web application or web job that sits between the user and the foundation LLM with predefined prompts and system instructions. And this is the perfect choice for AI-related use cases such as documentation generation, where we provide all required information as an input to the LLM, and with defined instructions, it can generate the required documentation. And this is actually exactly how we use it for our customer to generate shipment documentation. This workflow is shown on this diagram. Employees use very simple ChatGPT-like interface where they can provide information about shipment in a free form, and system will generate the required documentation that users can review and edit if needed. Prompt engineering also could be used to create AI-driven checklists for compliance, to translate policy documentation, to perform sentiment analysis for feedback, to summarize production report, and many, many more. Corporate LLMs comes into play when we need to extend foundation models with corporate-specific data. Usually, we use RAG, retrieval augmented generation, as a quick and efficient solution to enrich pre-trained models with domain knowledge. Here, we transform customer data from different sources like websites, databases, documents, emails, and so on into AI-ready intelligence. During this transformation, we use anonymization and masking to protect sensitive data. And at the end of this process, we have different LLMs that has access only to that data that needed and not to the entire knowledge base. This also helps eliminate AI hallucinations and create a conversational layer on top of the corporate data that also can be easily integrated into your existing ecosystem, like Microsoft Teams or websites, additionally providing features for accessing corporate data, such as using different languages or voice. And from the technical side, we use vector storage for that corporate knowledge base, embedding models to transform raw data into vectors, and cognitive search to augment the foundational LLM with data relevant to user requests. And we use this approach to create a shipping support chatbot for employees and clients that helps with documentation. Additionally, with specific rules, it has information about different VAT forms, restrictions, and so on. The interaction with this chatbot is pretty straightforward. User asks questions in free form and receives answers in conversational manner. Also, corporate LLMs can be used for interactive AI-driven training materials, for the HR department with domain-specific knowledge, for upsell opportunities with personalized offerings, for safety compliant guidance, product recommendation engines, and so on. AI workflows combine previous steps with an orchestrator that automates business processes with predefined rules. So at this stage, we have enough automated operations developed in previous stages that we can connect them together into one complex workflow, and using this orchestrator that triggers different operations, aggregates and evaluates results, and chains together different flows based on predefined rules. AI here plays multiple roles within these workflows. First, it can act as an intelligent decision maker, so analyzing data and determining which path of that workflow should we take based on the context and business logic. So for example, it could evaluate document content and decide whether to send it for immediate processing, flag it for human review, or reject it entirely based on quality or compliance criteria. Second, AI can function as a worker, a component with an automation job that performs specific tasks like data instruction, classifications, or generation, together alongside with traditional automation steps. Also, what is powerful about this level is the flexibility and scalability it offers. Individual AI workflows can themselves become building blocks for even larger, more complex workflows. So you can nest workflows within workflows, creating sophisticated multi-tier automation systems that handles enterprise scale operations. AI can continuously evaluate results at any stage and dynamically adjust the execution chain if needed. For example, if initial results don't meet quality threshold, the workflow can automatically trigger alternative processing paths or escalate to human review. Integration is another crucial advantage of AI workflows. So these workflows can be seamlessly integrated into your existing business system and triggered directly from those platforms, whether it's your CRM, ERP, Messenger, or custom applications. So you don't need to replace your current infrastructure. AI workflows extend and enhance it. And perhaps most importantly, AI solves integration challenges where previously was difficult or even impossible. So systems that could not communicate before now can be connected through AI-powered integration layers, and AI can understand and transform data between disparate formats, interpret unstructured information, and bridge the gap between legacy system and modern application. As an example, we automated the complete shipping process by connected integration with external APIs that was developed on non-AI automation step, and corporate LLM for additional shipment context, decision-making, documentation generation, sending some personalized notification with updates, and so on, and all together as building blocks into one solution. So automated shipment process is illustrated on this slide. So after order creation, corporate LLM retrieves compliance-specific requirements from knowledge base, generates documentation, analyzes different parameters and calculates price, automatically creates booking via external carriers APIs, and sends personalized notification to users. Also, AI workflows could help with AI-guided computer vision for testing and calibration, lead scoring, and customer segmentation. Also, as well with AI-driven contract management and really many, many more. So now I'm passing the word to Yurii to dive deep into AI agents.
Yes, thank you, Vitalii, for giving the introduction to that adoption model. Okay, now let's move from the typical AI workflows to more complex scenarios to the world of AI agents. Before we dive in, let's define what actually we mean by AI agent, because there are different definitions for one. We usually treat an AI agent as kind of AI-driven tool capable of making some decisions on its own. Not just following some predefined rules, but basically building the plan by itself. Unlike the AI workflows, agents are more goal-oriented. So you give them the objective and the tool to achieve that objective, and agent should figure out by itself, step by step, how to do that. In a concept, that seems pretty simple. After all, any one of you can just go into ChatGPT and create there some basic AI agent. By building some good enterprise-level agent, which is reliable, safe, and effective for your business processes, is a bit harder task. So typically, any AI agent consists of 4 building blocks that are the persona, memory, tool, and model. We will explore each of them in the next few slides. The first one is the agent persona. It's the identity and behavioral profile of your agent. It actually can be something very simple, where you just define you are a helpful assistant, or you are a financial advisor, something like that. But in more advanced system, we define it more complex. We define the agent tone, we define the expertise level, what tasks can and cannot do, what are the scenarios that particular agent should avoid, and something like that. We can also give an example of successful, the happy path interactions to guide it. And by the way, we usually didn't provide, so we avoid failure cases because sometimes agents might misunderstood that and use that wrong cases as example of happy paths and so on, and do some wrong reasoning. Over the time, your persona of your agent can be improved. It can learn for user preferences from adapting its style based on feedback, interactions, and so on. So in short, persona defines who your agent is and how your agent behaves. Next comes the memory, which essentially how the agent manages your data. That include all connected data sources, the databases, the APIs, maybe some vector storage, the conversation history, basically any data sources, internal or external, that might be helpful for that particular agent. And that also includes a set of rules, actually, how to manage the data. So not only the data itself, but also some rules how to work with that. For instance, it defines how much context the agent can retain, or how far back in the history he can jump back to look something, when he should summarize the older messages, how to keep it working efficiently, and how to rank retrieved information from any data sources by some relevance and so on. Some agents operate actually with a minimal memory, so it's just a simple case. You can just provide a simple prompt, and basically it can be considered as a memory for the agent. Other uses a more complex setup with multiple data sources, with retrieval augmented generation, which Vitalii mentioned previously, with synchronization, data compression, in order not to hit the limit of LLM models and so on. But in short, the memory is what lets the agent retain the context, reason across the session, and use your knowledge base efficiently. The third part is arguably the most important one, part of tooling. Without tools, your agent can't do much. Tools are what enable agent to take action, any action, from reading from external source to triggering some existing workflows, maybe sending some notifications to user, interacting with some system, and so on. That can include actually some ready-made integration like Google Calendar or Gmail that allows your agents to read your messaging, write emails from you, check your calendar, and so on. And it can also integrate some custom code written by yourself, so you can wrap it into some specific model context protocol that allow your agent to communicate with that and use that custom reading code. Moreover, there are actually a set of tools that allow you to convert, for instance, your existing .NET API into a tool that can be used by agent. So it lists all the capabilities of your API to that agent. Now he understands what he can do with that API and can use that in scope of solving the tasks. Actually, even the AI workflows from earlier slides can be treated also as a tool. For example, a notification workflow for shipment tracking process. When necessary, agent just trigger that workflow and it starts doing its job. Or moreover, you actually can make one agent a tool for another agent, and they will just calling it each other. The challenge here is the balance. If you give the agent too many tools, or maybe if your API give a big amount of endpoints that are complexly chained, so for instance, to get some information, you need to call like 5-10 endpoints sequentially, that might confuse the agent a bit. And it will not understand which tool to use, so it will lead to some unpredictable behavior and probably not solving your task so accurately. The final part of any agent, last but not the least, is the agent brain. This typically any large language model such as GPT, Claude, and others. Sometimes you can fine-tune the models for like smaller, lightweight tasks. Or maybe when you need a specific type of heavy customization for your particular case. And just general foundation model is not okay for you, so you can fine-tune the open source solution like Llama and use that as a brain of your agent. Basically, the model is what the enterprise user intends, perform reasoning, decides how to use the available tools, and give the actions to the tools to do that. That's what about agent. Now let's take a moment to compare the AI workflows and AI agents to understand the difference. Workflows are structured and predictable. They follow the defined set of steps, rarely make mistakes, and are great for high accuracy automations. But they lack flexibility, they can't handle new unexpected situations, and so on. AI agents, on the other side, are adaptive, they are goal-driven, so you just define an objective and agent decide how to achieve it, which tool to use, what data to retrieve, builds a plan, which step to take, evaluates that plan, retry if it's necessary, and so on. But with this flexibility comes with trade-offs as well. Higher error rates, more complexity in governance, debugging, and so on. Usually when you have a well-defined process pipeline and understand all the steps, you should go with AI workflows. For more complex scenarios, when flows are too complex or can dynamically change, the most common example are the customer support, where you do not understand, do not know what a particular customer will ask and what problem he has and how to solve it. Then probably you need to go with AI agent and can skip the workflows part at all. But in practice, most of the system are actually the combination of both. Workflows for reliable problems where you have the actual steps you need to do, and agents for adaptability and for tasks where you doesn't know what decision you need to make before starting the task. So here is what an AI agent architecture look like. You can interact with it with multiple channels. That might be the web app, that might be your Microsoft Teams corporate or any other corporate messenger, that might be some chatbots, or that might be background trigger, which is not visible for a human, just reaction to some system event. For instance, a new user created or some order placed, something like that. And when triggered, the agent accesses the tool, retrieves context from the memory, plans how to solve particular task with current tool set provided to him. Behind the scenes, they rely on various techniques to make the process effective, but it's kind of technical discussion and maybe a topic for a different webinar. So all of that make agents powerful for dynamic, real-time decision-making. Now let's to our concrete example, the intelligent shipping assistant that we are actually developing currently. In this case, when the system detects a shipment delay, it automatically triggers the logistics AI agent, and the agent check possible alternatives in delivery via APIs. Also queries some corporate knowledge base for regulations, and when needed, adjust the delivery methods. For example, switching from ground delivery to air delivery. As a result, it updates all the necessary connected systems, notifies the customers with a Twilio, basically just the SMS notification or any messenger notification, and completes the rerouting without human intervention. Actually, to be honest, on the current stage, we still keep manual human approve because we're still evaluating this solution. But it's not much activity in comparison to what we have before with a lot of manual processing. And of course, our ultimate goal is the full automation, where even that manual approval by human will be not required. The next step in evolution of agents are the multi-agent system. And here, instead of a single all-purpose agent, we have the multiple specialized agent that handle smaller, well-defined tasks. Each one focuses on its own domain. For instance, text generation or image recognition, data analysis, and so on. This agents communicates and coordinates through an orchestrator, similar to like just department in your organization are communicating to each other. Or they can actually even talk to each other by skipping the orchestrator if necessary. It's up to you how you define their communication policies. This approach helps to overcome the current LLM limitations since they are not the AGI yet, and we replicate that intelligence capable of handling complex tasks through collaboration of multiple task-tailored agents. So instead of using single massive model that is overwhelmed by tool number, we'll quickly lose the context. We build multiple smaller agents that just can split the work and communicate to each other. In our logistic example, the multi-agent system is not in place yet, but might look something like that. So we have a logistic agent that selects the carrier and book the transport. We have the customer agent that are responsible for handling any customer communication, sends notification and updates the necessary information. We have the financial agent that recalculates VAT, maybe prepare some invoices and so on. And orchestrator that coordinates the process, updates the ERP system, and that setup ensures every subsystem can communicate seamlessly, achieving a full integrated enterprise-level workflow. Also, it can be used for many other use cases, not limited with this one. And as you can see, even this diagram looks much simpler than the first one we showed on the first slide with multiple decision steps and so on. So in general, that agent and multi-agentic system simplify and automate a lot of work. Now, a quick word about the machine learning. It's like a more traditional side of AI. ML has been around for decades and remains actually essential for tasks like forecasting, pricing, recommendation systems, and so on. Its drawbacks in comparison to modern Gen AI approach is that it requires heavy preparation and resources and development, especially from the data side. Usually you need a team of data engineers, data scientists, ML engineers to train your own model, and so on. This process involves data set analysis, data labeling, data preparation and processing, training, all of which are resource intensive and actually time consuming. Moreover, typically you will not able to do a good model in one shot. You need to repeat the multiple iteration to build a good model and continuously improve it over the time. But once trained, that model provides a significant predictive power, as I mentioned, for the predicting, delivery delays, optimizing pricing dynamically, or building some recommendation systems that adapts on the fly. Just like one you might see in Instagram or TikTok, where you start paying more attention to a certain type of content and system quickly begins recommending you more and more of that type of content. That's actually the pre-trained model that continuously learning from the new inputs and so on. But from our experience, sometimes even the agents can replace some small machine learning tasks through reasoning and proper tool usage. Simply, you can provide to your agent tools to access your data, writing a good persona description that might cover simple scenarios and prediction, and it will be capable to do some feasible prediction for your specific case. Of course, it will not cover some heavy, complex tasks, but if that works, why not to use it? The benefit is that you can set up it pretty quickly. So it might take days or weeks to do such type of integration instead of classical approach with machine learning, which usually takes a month. So it's still a good chance just to try and see if it works. If not, then fall back to regular machine learning approach. Also, when talking about the AI, we can skip the security part. In fact, the proper security system are built from a combination of various measures. First of all, it's dedicated deployments. This is about the securing data from the LLM itself. So ensuring it's not used for the future model training and your data is not used for that. You can achieve that by using a dedicated deployment. For instance, Azure OpenAI or using of enterprise model plans or by deploying your own open source model like Llama on your own infrastructure. Typically, it's not so popular because that is cost ineffective and that models are not so powerful as foundational models. So typically users start with some foundation model like ChatGPT and Gemini and so on. But using the dedicated deployment in order not to leak your data for that model training. The second one is the data masking. Vitalii already mentioned about it. It's to anonymize your sensitive data before sending it into the model, especially in some regulated domains like healthcare or finance. For example, to make a certain decision in your processing pipeline, you probably don't need the user first name or user last name. You can anonymize it, hide that information, do the processing, and on the later stages, fall back to the original user first name and last name to show to the user. But on the step when the LLM is processing that, it doesn't know anything about that user. It just in case. So you can anonymize data before providing them into your large language model. The next one is the isolated storage. So it's to give each agent access only to the data it needs. Avoid building large centralized storage that contain all information. This helps physically to prevent access of an agent it shouldn't see. Otherwise, some agent might try to use tools provided for him and retrieve some data that actually was not designed to be used by that particular agent. That can affect as wrong behavior of that specific agent and some data leakage as well. The next one is user personification. You probably should let your agent act under the permission of user who is currently interacting with that agent to prevent an unauthorized data access. For instance, imagine a new employee just came to the company and opened the agent and asking for the financial information of the company for the last year. Probably you don't want to share that information for the newcomer and so on. If agents are operating from some admin permission level, probably it will have access to the data, and that is the security leak. The newcomer can easily access to any data that is in your system. So you should build the system in a different way, where agents are operating under the permission of the user who is interacting with him. So if that particular user doesn't have access to the data, the agent also doesn't have access to the data and basically cannot retrieve it in any way. So you are secure in that case. The next one is the observability. You should log your action, your queries, any decisions and made by agent for transparency and the future debugging. These logs can be used for the analysis, to improve your agent performance, to do new iteration when you reevaluate its work and want to create a new iteration, new version of your agent. You can analyze that data. And in case of potential issue, it might allow that to troubleshoot work of that agent. And probably the most important, all these measures should be built in from the very beginning, not added later to the system, because it's quite complex and might bring unnecessary timeline in developing or reworking your agentic system. So how do you actually start adopting AI into your business? We usually begin with a discovery phase, understanding your processes, identifying potential automation points, and estimating the impact. At this stage, it's important to focus on initiatives that brings the most visible results, those that address you the most critical scenarios and deliver quick wins. Our experts who understand both the possibilities of modern AI and the specifics of your potential business workflows will help to map those opportunities and highlight potential improvements. Typically, that phase lasts 2-4 weeks and includes several Q&A sessions along with set of artifacts produced as a result. Then we move forward and we prepare the foundation for future agents, integrating the data, setting up the right tooling, and make system ready for the further improvements. Sometimes you already have that, and that step can be skipped, but usually you need to assess it before moving forward. Then gradually move up the ladder and start with simple prompt engineering for prototyping and feasibility testing. Or you can build a robust corporate LLM for internal knowledge management. Depends on what is more suitable for your case. Then add an AI workflows on top of that for the structured tasks and high accurate result. And finally, implement the AI agents to handle more complex scenarios. Each of that stage is usually an evolution of the previous one. That ensures the stability, the scalability, and security through whole the process. Finally, a few words about Leobit real project that we developed previously and some project that our R&D team implemented. The case study that we have mentioned during the webinar can be found with the first link. Other showcase our AI and ML project across different levels of complexity and domains. Some of them use AI as a core product feature, while other AI plays more supportive role automating and optimizing processes like behind the scene. This even includes our internal tools such as Leona, which we actively use for RFP scoring and so on. Also, our R&D team developed several proof of concepts. That are the small demos of AI scenarios that can be building blocks for more complex workflows. Each of these projects usually started as a small, often a proof of concept or MVP, and evolved through the adoption stages we discussed previously. So you can explore them on our website and get some inspiration from there. So the final takeaways from us would be start simple and then gradually enhance your usage of AI. Because you can cover some scenarios already today without even usage of development team by simply testing the feasibility with prompt engineering and something like that. Hopefully, this webinar will be a good starting point in your AI journey. We're happy to take your questions.
Yeah, thank you, Yurii. I see that we have a couple of questions. So let's start with the first one from Ramazan. This adoption model, is it suggesting that you should not move to level 1 or 2 without level 0? In other words, is it incremental?
Vitalii, will you address that?
Yeah, but actually, I think partially you already answered it on the slide with adoption roadmap. So of course it can be skipped, but it's on the beginning it requires like proper discovery phase or assessment to assess what you already have in place and what can be reused for building AI agents. And also it depends on the complexity of the specific cases, because we really can use even some agents SDK and build simple agents very quickly with some like even simple prompts. It could be done even with hours. And this already will be working, but some more complex solution will require some data preparation for that, and also a toolkit or tooling that will be used by those agents that needs to be created. Hope this answers the question.
Thank you, Vitalii. The next one from Tom. Hi, thanks so much for the great session. Thank you, Tom. How much time is needed to create an AI workflow and an AI agent that perform approximately the same set of operations?
Well, usually it depends. It depends on the complexity of the scenario you need, because as I mentioned, sometimes you can just, this doesn't need any knowledge base, doesn't need any good persona description. So we just write something and it's already capable of solving your tasks. But in general, probably AI agent will be simpler to build because it doesn't need to define each step, each rule, how to make a decision separately. So usually AI agent is quicker to build, but probably it will be less reliable, less accurate for your system. And it can depend from the days, probably to the months, as some of our agents are continuously improving. So we are doing like release probably each month, which improves something in the agents. So that depends.
Thank you, Yurii. And I see the last question from James. How can my files serve as a knowledge base for an LLM?
Yeah, so usually, again, if we talk about RAG approach to retrieval augmented for the corporate, to build in corporate LLM, so it depends on different types of the file. So for example, we have emails or already some real files like PDFs or Word documents, whatever. So usually we create some small tools that can extract the text or the content from these files. We run it through embedded model, and like the result of this run of that embedded model would be vector, and so we will store these vectors in containers in vector storage. And then when user will ask some like request or some question, firstly it will trigger like the cognitive search that will do like vector similarity check, and your like vectors that were created based on your files will be picked up and then translated into the content that were stored in those files. So in general, it could be any file that could be, and that content we can extract from. So usually it can be even just a website, so we can scrape HTML pages and put it into and run it through this embedded model to convert the vectors. Could it be emails? Could be even like voice recordings, because this voice recordings we can make a transcription of it, so we will receive the text of it and then again run this text through embedded model to convert it to the vector to make the efficient similarity and very fast similarity check in this knowledge base. And this as the additional context will come to the like foundation model or pre-trained model, so like user request, relevant information from the knowledge base, some system prompt instruction will come to the pre-trained foundation LM, and this will give the answer to the end user.
I'll just add, because Vitalii dive a bit into the technical aspect, but in general, you just collect all the data which is valuable for you, any type of data, media, text, databases, and so on. Place that in specific place and ask AI to investigate that information. So when you're doing a further request to it, it already knows what is there and how to work with that. It usually takes even more time to collect the data and place that in proper way than learning your agent on the data itself.
And also additional comment on top of that, it's also important here to create some, let's say, pipelines or jobs that will update this data, because with the time, some portion of the data will be updated, you will create a new portion. So it's important to run it on some regular basis, again, through embedded models, and collect even more and update knowledge base with the actual information.
Thank you, guys. So we will be finishing our webinar. If you are further interested in this topic, feel free to contact us for AI audit. We'll be happy to speak with you about that. And thank you for joining our webinar. Thank you, our great speakers, for sharing insightful information. Just a small reminder, we will send the recording to your emails, so please keep an eye on your inbox. And hope to see you in our next webinars soon. Have a nice rest of the day, guys. Bye-bye.
Thank you. Bye-bye.
Bye.